All right, so today we're going to be working on our LVIs, which is a large volume injection water. We're going to a little bit about how we have set up here. We have our vials set up with our samples we're going to be working on today. We also have our caps that we're going to be using for our vials. We have our deionized water pump right here that is calibrated per quarter. We're also going to be utilizing our methylene chloride pump, which has also been calibrated. And it's a special 2 milliliter pump that we use specifically for this test. For most LVIs, we also utilize salt, which we have set up right here, that we're going to be using in a moment. And we're also using our syringes for each test, as well as the standards we're going to use today. And then last, we also have our scoop that we're going to use in a funnel for our salt once we get to that stage in the process. Okay. Now that we have everything set up with our glassware labeled, our glassware has also been rinsed with methylene chloride prior to use, so it is all ready to go. We're going to start off by adding 40 mils for our initial volume of deionized water to our blank LCS and LCSD. Okay. Now that those are prepped, we're going to get to our actual samples we have here. Now each of these are in a 40 ml VOA container. So how we prep these is we simply open the vial like this. We're going to have to go through and mark the meniscus for our volume verification later on. So we'll be marking our meniscus like this with a blue paint pen. And then what we'll do is we'll simply pour it into our container. And being careful to avoid any sediment that may be in the vial itself. Like so. And then we'll keep the container for our volume verification, which we'll utilize later on. And we'll do the same for all the other containers as well. Making sure to mark the meniscus with the paint pen. And then pour our sample in. Alright, so now that all of our QC samples are poured up using our 40 mils of deionized water, all of our actual samples are poured up, and the meniscus is marked for the volume verification, which we'll utilize later. We're going to go through and start to add our spike and our surrogate compounds. So first we'll add our spike compounds to our LCS, LCSD, or MS-MSD if applicable. Now for LVIs, since the spike and surrogate amounts are usually fairly small, you want to make sure to get right at the surface to make sure that you can inject properly into the solvent. There we go. Okay. Okay, now we've added our spike compounds to our QC. Now we're going to move to our surrogate compounds, which we're going to add to our QC and all of our samples. And once again, for our surrogate, being that it is such a small amount, we want to make sure to keep it as close to the surface when we spike as possible. Alright, so now that we've added our surrogate compounds, it is important to note that depending upon the amount of surrogates and spikes that you add, it is also possible to use a rinse container separate, so that in case you need to inject right into the sample itself or the GI water, to have a rinse vial with methylene chloride on hand, to simply inject, rinse, and move on to the next sample to prevent any cross-contamination between the samples themselves. But for this test, the amount is large enough, we didn't necessarily need one. Now that we've added our spike and our surrogate compounds, we're going to utilize our methylene chloride pump, which has been calibrated. Now with such a small amount, we want to prime the pump every time before use. So having a separate container like this, simply pump a few times to make sure that the line is clean and there are no air bubbles present. And once it's ready to go, then you can begin adding your 2 mils of solvent to each of your QC and samples. So, now that we've added our methylene chloride, our 2 mils of solvent, we're going to go through, we're going to add our sodium chloride. And to do that, we use a special scoop that we keep strictly for LVIs that has been rinsed beforehand, and a funnel with a wider hole to allow the salt to pass through easier. That's what we do. And this salt has been crushed up prior to make sure that it's nice and grainy and easy to flow. We'll take a half a tablespoon, that's a level scoop, and we'll just hover right over the top and add 1 scoop of salt to the tap. Now we want to make sure not to set the funnel directly onto the vials because that can cross-contaminate from sample to sample. So you want to hover just slightly over like that. You're going to want to add a level scoop to each sample. Okay, so now that we've added our spike compounds to our LCS-LCSD, our surrogate compounds to all samples, our solvent and our salt, we're going to go ahead and cap them and get them ready for shaking. Now, since LVI tubes have a conical base to them, we've made a makeshift base for our shaker that's double layered like this to make sure that the tip doesn't push through and accidentally break while we're shaking. So we've made a special container for that. So now that we're all ready, we're going to add our top and we're going to add it to our mechanical shaker now. Okay, so now that we've shaken our samples for 10 minutes using either mechanical shaker or by hand shaking, we're going to bring them over to our centrifuge, where we're going to centrifuge for 15 minutes at 500 times the gravity. Now each centrifuge is different, but for ours we have a special conical holder that we use to fit our LVI tubes. And so we'll just want to gingerly secure these in here so that they're all balanced on all sides. And since we have an odd number of samples, we're going to use a reference as a placeholder. We're just going to make sure that it's lined up and balanced on all 4 sides like that. And what we're going to do is we're just simply going to shut the door. And ours, it's set to 500 times gravity at 15 minutes, so we just press start. Now that our centrifuge has finished its 15-minute runtime, we're just going to inspect all of our samples as we pull them out to make sure everything's okay. All of our solvent lines look good. We'll inspect these. Now with actual samples, you will tend to get, emulsion in the layers, but that's perfectly fine as long as your solvent is clear and easy to see. Okay. Looks good. Okay. Now for most of our LVI tests, we utilize methylene chloride as our solvent, which is like the bubble that we saw down here at this one. For one specific test, which is a TPH Kansas, it does use hexane instead of methylene chloride. So instead of the solvent being at the bottom, you'll have the solvent line at the top, which looks like so. So the final stage for LVIs, we're going to transfer it to our final vials. But for this process, we use what we call a double transfer. So what we're going to do is we're going to take our centrifuge samples that we have here. We're going to extract all of our solvent from this container. We're going to add it into a 1.8 ml vial that has been added with some sodium sulfate or some kind of drying agent to clear up any emulsion or water that you may get. After we add our solvent to that, we're going to shake it for about 30 seconds. And then from this vial, we're going to transfer it to another labeled vial for final analysis. So, to start off with, we'll start with our QC. So for this, since our solvent is down at the bottom of this tube, we're going to want to go down it with our pipette, release all the air from our bulb, and then slowly draw up all the solvent that we have, like that. And then we simply add all of that solvent to our vial, like that. Then we can even go back in and get the last little bit like that. And any water that is accumulated will be picked up by the sodium sulfate. There's no worries. Once we have all of our solvent that we're collecting, simply cap our vial. Give it a good shake for about 30 seconds, just to make sure all the water and any emulsion is taken care of. And then once that's really done, we can go back and finish the rest of our samples like that. So now that we've transferred all of our solvent from our LVI tube into our first vial, which had our sodium sulfate, we're now going to transfer 1 ml of this into our labeled vial for analysis. And we're going to do that using a reference vial which is made today using a syringe for 1 ml. So what we're going to do is just simply draw out solvent, and using our reference vial we'll simply bring it up to that reference line. And if necessary, and then from there, we'll cap. Okay, so now all of our samples have been transferred from our first vials with the sodium sulfate into our clean vials that are labeled and prepped and ready for analysis.